Continuing with section 7.5, let us look at the next example. So previous examples, remember I showed you that if you have a single term, trig expression, so for example here in this example we had cosine of 2 theta, and so we can write it as cosine of 2 theta equal to number which we had 3/4. And so actually this was cosine square 2 theta, sorry. So the cosine square 2 theta, and so but that was just single term, single trig term. So now in the next example we are seeing two trig terms, and they are not, at this moment we cannot combine them. So what should we do with that? Well, our only kind of chance is to rewrite cosine of 2 theta in some other way, not in this form. We should try to convert the form of cosine of 2 theta. Reason, because cosine of theta, we have less options to change. So we cannot change cosine theta. There is no identity for that. The identity, if there is, it is for cosine square theta, not for cosine theta. This is a common mistake students do. Because we have that sine square theta plus cosine square theta is equal to 1, students think sine of theta plus cosine theta is equal to 1. This is wrong. Okay, this is wrong. You are not supposed to do that. Also, we see from the first identity here, this is, remember, the Pythagorean identity. So we have from here that sine square theta is equal to 1 minus cosine square theta. We do not have sine of theta equal to 1 minus cosine theta. We do not have any such identity. So, and in the same way, we have cosine square theta equal to 1 minus sine square theta. We do not have cosine theta equal to 1 minus sine theta. So do not create or make up identities on your own or what you think are correct. Follow the rules and accordingly write the correct identity. Use the correct identity. Okay, so now our chance is to rewrite cosine of 2 theta into some other form. What other form? Well, we have learned recently there are 3 forms in which we can write cosine of 2 theta. Now these are called double angle formulas. Now in your online homework you might have noted that the question says use double angle formulas or half angle formulas. Well, you have not done you have not learned we didn't teach you the half angle formulas. So you only know at this time the double angle formulas. So you are just going to use these because they are saying use double angle or half angle. So if you know both, you have a choice. If not, then whatever you know, you have to use that. Okay, so what are those formulas? There are one is for sine 2 theta. Sine 2 theta is equal to 2 times sine theta cosine theta. So why are we calling them double? Because can you see on the right hand side we have theta, and on the second and left hand side we have double of theta. So if we have the double angle, how can we write it into single angle? That's what the double angle formula does. It changes from double angle to single angle. Half is in inverse of it. Half angle formula changes half angle or a angle to a double angle. Okay, so the cosine theta 2 theta though has 3 forms, which you have seen. Actually, we have proved them in we verified them in section 7.1, I believe. Okay, so one of the forms is cosine of 2 theta equal to cosine square theta minus sine square theta. Okay, so second form is cosine of 2 theta equals 2 cosine square theta minus 1, and then the third one is cosine of 2 theta equals 1 minus 2 sine square theta. So when we see cosine of 2 theta, we have to figure out which form will be helpful. Now, if you can memorize all these forms, it's very good, but at least you should know this one and you should know this one, and then you should be able to get these other two from this form. Can you see? In the, let me call this 1, 2, 3. From 1 you can get 2 by doing what? By changing this sine square as, writing it as 1 minus cosine square, and then you can get the third form from the first form by changing the cosine square into 1 minus sine square. So either memorize them or know how to get them. Okay, now coming to the equation given. So note here we have cosine of 2 theta and cosine theta. So which form will we use here? So if you recall, I have shown you how to solve these trig equations which look like quadratic, okay, or we can say which are of quadratic form. So I can make it a quadratic form, but for that, remember the term which is squared should be the same as the how to say, the single variable term. So remember, like x square, if I have x square, then in whatever the single variable will be, that should also be x. I mean, so I can have an a here, even ax square plus bx, not by, not bt, plus c equal to 0. So we should say this actually, whatever the variable, the square should be of that variable. The square term should be of that variable. So in here we have cosine of theta, which we can substitute as u or z or t or a or whatever you want. So square term also be the same variable. So the square term should also be cosine square. So if I use the first expression here, if I use this one, the first one, then I will end up getting a square of cosine and a square of sine. I don't need the square. I don't want the square of sine because that's not going to help me. So if you use this, you can actually start there, but then you will have to convert the sine square term into 1 minus cosine square. So you end up getting this second expression. So if you already know these three expressions for cosine 2 theta, just pick the right one. So the right one is the 2 cosine square theta minus 1. So I will do that. Okay, let me clean it. So we write it as 2 cosine square minus 1 plus 7 cosine of theta equals 8. Okay, now what do? We bring everything on one side, and then we will subtract the 8 in order to do that, and then we get 0 on the right hand side. So we'll combine the 8 with this negative 1 we have, and then this will be a quadratic form. So I have 2 cosine square theta minus 1. Okay, let me write it in order. So plus 7 cosine theta minus 1 minus 8 equals 0, which makes it 2 cosine square theta plus 7 cosine theta minus 9 equal to 0. Now this is a quadratic form. Quadratic form. So you can say let u equals cosine theta. Then, so what happens then? We will plug in u for cosine theta. So we end up getting 2u square plus 7u minus 9 equal to 0. Now we need to factor this. So how do we factor this? Again, your a is 2, b is 7, and c is negative 9. Okay, b is 7 and c is negative 9. So what do? You find AC. AC is negative 18. So you want factors of negative 18 that will add up to a plus 7. So remember, 9 times 2 is 18 and 9 minus 2 is 7. Because you want the plus 7, it means the bigger factor will have a positive sign with it. So the factors I need are plus 9 and minus 7. Minus 2. So plus 9 minus 2 gives me 7. So see, I can write it like this, 7. I can write 7 as 9 minus 2. So I can write 7u as 9u minus 2u. So now I will replace the 7u over here by this factor, this expression. So I end up getting 2u squared plus, now remember, 7u is going to be replaced by 9u minus 2u. And then we have our minus 9 as it is equal to 0. Now we have 4 terms. So what do we do now? We will factor by grouping. So when we do grouping, we will group the first 2 and then we will group the second 2. How do we do that? Well, we try to see, can we factor something from the first 2? So you note that yes, we can factor a u. So we put the u here. What is left inside? Over here, first term, we are left with 2u, and then plus in the second term, we are left with 9. Okay. Then we always remember, this is very, very important, the sign. Whatever is the sign next to the second term or in front of the third term. So if it's a plus sign, you'll put plus here. If it's a minus sign, you'll put minus. So we have a minus, so I'll put minus, and then I'll put parentheses, because now I want to see what can be factored from the next 2 terms. So we see from the next 2 terms, basically we can factor 1, because there is nothing common. So we are left now with the u, 2u. Now this is important. Often students write this, which is wrong. Why? Because remember, when you put the parentheses here, you are actually, what you have done is you have taken the negative 1 factored. You have taken the negative 1 out. So what is left inside is 2u plus 9. And also, this is kind of a hint that these 2 must be the same. This and this, they must be the same. If they have different signs, it means you have made a mistake somewhere. Okay, equal to 0. Don't forget the equal to 0. Often again, that students forget that. They get so involved in doing the left hand side or simplifying the left hand side, they forgot it was equal to 0. Because if there's no equal to 0, there's not an equation. This becomes an expression, and we don't want the expression, remember? Sorry about that. Okay, so what we do next? We can now factor out 2u plus 9, and then we have u minus 1 equal to 0. So which means 2u plus 9 is equal to 0 or u minus 1 is equal to 0. The first one gives me u equals negative 9 over 2, and the second gives me u is equal to 1. Now we can go back and replace the u by what it was, which means cosine of theta equals to negative 9 over 2, and cosine of theta equals 1. Now what? Can you see this will be no solution? Why? Because remember, this is exactly actually negative 4.5, and which is less than negative 1, and we cannot have a number less than negative 1, so therefore no solution. The second expression though will give us a solution. So when is cosine equal to 1? When theta is 0. The primary solution will be 0. Is there any other place where theta is 1? Cosine theta is 1? Well, on 2 pi, 4 pi, 6 pi and so on, but for the primary solution we have to stay within the one circle between 0 and 2 pi, where 0 is included and 2 pi is not included, and we write the interval like this, 0 comma 2 pi. So this bracket shows not, the endpoint is not included, this bracket shows the endpoint is included. We sometimes call this square bracket as closed bracket, and this one of parentheses is called an open bracket. Open means the endpoint is not included, closed means the endpoint is included. Okay, so now we end up getting cosine of theta is equal to 1, so we end up getting theta equals 0 plus 2k pi or just 2k pi. So this is the general solution. So notice here this equation or this example, we are not now getting things like we had before. Remember in the previous example we had we had cosine of 3 theta equal to something, so then we first step in solving, after getting a simple trig equation, we got 3 theta equal to several values, and then we had to divide by 3. Here we are not getting that 2 theta. That 2 theta is gone. Why? Because remember we converted it into, we used the double angle formula to convert it into single angle. So we have theta is equal to 2k pi. That is the solution. Well, I just wanted to show you one more quick example here. So we are doing, so what if you have, so this is an extra example. What if you have your, you have sine of 2 theta equals square root of 2 over 2. So you will start, the first thing that you will do is look at what the simple equation is. So think of it like sine of x equals square root of 2 over 2. So you will say x is equal to pi over 4 plus 2k pi x is equal to pi over 4 plus 2k pi, and then x is equal to 3 pi over 4 plus 2k pi. Okay. So these will be the general solution for that type of equation. Over here we have, instead of x, we have 2 theta. So what? It's exactly the same thing. So instead of x, On the left side, I will say 2 theta equals pi over 4 plus 2k pi. And then 2 theta equals 3 pi over 4 plus 2k pi. But now, because I want theta, so the first equation will give me, so from here I will get theta is equal to pi over 8 plus k pi. And from the second equation I'll get, so this will give me theta equals 3 pi over 8 plus k pi. Okay, so these two form the general solution. Okay, so these are general solution. Now for the primary solutions, k is equal to 0 plus minus 1. Don't forget this, please. So now, so I have to do that in the previous example as so here k will be equal to 0 plus minus 1 plus 1 and so on dot dot. Okay, so now for the primary solution, we will just plug in the values of k, but we will only use the positive values. So if you want to make a list, you may, or you can directly just in your head do it, or you can do it on a separate paper. So I'm just going to do it like the work on a side. So I'm going to write a primary solution. And we will try to see for several values of k, and we will stop when the value at the angle we get is going to, if it is bigger than 2 pi, then we will not include it. We will stop there then. So first thing we do is when k is 0. So from the first equation I am getting theta is equal to pi over 4. From the second equation I get theta is equal to 3 pi over 4. When k is 1, I get theta equals, so I can do the calculation on the right hand side here. So I get theta equals pi over 8 plus pi, because k is 1 now. So but that gives me 9 pi over 8. Sorry, this is my mistake here. This was 8 and this was 8. Okay, so pi over 8, and then I have 3 pi over 8. Now next one will give me 9 pi over 8, and the second one will give me 3 pi over 8 plus pi over 8 plus pi, right? Like what we have here. So what will that give me? 8 plus 3 is 11. So we get 11 pi over 8. Okay. If I take k is equal to 3, k is equal to 2, what will happen now? First equation will give me pi over 8 plus 2 pi. which is going to give me 17 pi over 8, which is more than 2 pi. How is it more than 2 pi? Because 16 pi over 8 will be equal to 2 pi. And here we have 17 pi on the top. Instead of 16 pi is going to give you 2 pi. So anything more than 16 on the top will give you an angle more than 2 pi. So we cannot have that. In the same way, when you plug k is equal to 2 in the second equation, it will give you pi over 8, 3 pi over 8, is it? 3 pi over 8 divided plus 2 pi. So which will give you 16 plus 3 is 19, which is again more than 2 pi. So these are our 4 primary solutions. Okay. Let's look at the next example. Okay, so now here, this is interesting. So I have on the left hand side, I have 2 sine square theta, and is equal to 2 plus cosine of 2 theta. Now this one, what should we do? Well, I can write sine square theta as 1 minus cosine square theta, but will that help? Well, not in this form. We will have to change this as well, right? So you can do it that way. You can change the sine square theta here and write it as 2 times 1 minus cosine square theta is equal to 2 plus. So now again, this must be then, you should use the version where cosine of 2 theta is equal to 2 cosine square theta minus 1, so that you can combine the cosine square theta terms, and this becomes a from there you will be able to get the simple equation. Or another way to do this is, so maybe write it there. So the equation is sine square theta, 2 sine square theta equals 2 plus cosine of 2 theta. So this is our equation. So I can keep the sine square theta term as it is. I can write the cosine 2 theta as 1 minus 2 sine square theta. So what do you say? Okay, yeah, that works, right? Okay, so now I'm going to do that. On the right hand side, I will be okay, so I will write it like 2 sine square theta is equal to 2 plus 1 minus sine square 2 sine square theta. Because remember, cosine of 2 theta equal to 1 minus 2 sine square theta. This is one of the form of cosine of 2 theta. So that's the form I'm using here. Okay, now when you look, these two terms will get combined. We'll make it 4. And then here we get 3, which we can now write as sine square theta equals to 3 over 4, or sine of theta will be equal to plus minus square root of 3 over 4, which gives me sine of theta is equal to plus minus square root of 3 over 2. So we got two equations. One is sine theta equal to square root of 3 over 2, and the other one is sine of theta is equal to negative square root of 3 over 2. Okay, we will come back to this part. Let's go back to the other way. So if we were doing it this way, now distribute this 2. So we get 2 minus 2 cosine square theta equals to 2. Actually, 2 minus 1 here. So I can write it as 1. 1 plus 2 cosine square theta. Okay, so now what? Now we should be, I can move this term over there. So it will give me 4 cosine square theta, and I can subtract 1, so I end up getting 1 is equal to 4 cosine square theta, which gives me cosine square theta equal to 1 over 4, which means cosine of theta equal to plus minus 1 over 2. So now we get two equations over here. One is cosine of theta equals 1/2, and the other is cosine of theta equal to negative 1/2. Okay, so now what does this? So this one gives me theta equals pi over 3 plus 2k pi, or theta equals 5 pi over 3 plus 2k pi. Whereas the other one, this one gives me theta equals 4 pi over, not 3. One will be 2 pi over 3 and the other will be 5 pi over 3, 4 pi over 3. 2 pi over 3 in the second quadrant plus 2k pi, and the other will be 4 pi over 3 plus 2k pi. So now we try to see, is there any redundancy here that we can remove, because notice here this one, the first equation here, let me call it 1, 2, 3, 4. Okay, let me give the number and explain how we combine them. So this is 1 and so let me 1, this is 1, come on, so 1, this is 2, this is 3, and this is 4. So notice here the 1 is giving me the angle in the first quadrant, pi over 3. So this angle is pi over 3. And the fourth one, so this is the first one. So I'm going to put 1 here. So from 1 we get this. From 2 we are getting the angle in the second quadrant. Although this 2 is from that other solution, right? So these two we get from the equation cosine of theta is equal to 1/2, and these two we get from the equation cosine of theta is equal to negative 1/2. But notice how the solutions of two equations can be combined together to form lesser equations. So this one is 2. This is the 2 pi over 3. Then 4 pi over 3, which is the fourth equation. So 4 pi over 3 will be actually right there. This will be the 4 pi over 3. So this is the equation, the fourth equation. And then 5 pi over 3 will be over here, like extension of this line. So this will be the third equation. So notice here, instead of writing this and this separately, saying that theta will be equal to pi over 3 plus 2k pi, and then theta will be equal to 4 pi over 3 plus 2k pi, I can actually combine these two and write them as theta is equal to pi over 3 plus k pi. So which means it will be, its angle is starting here, then we go pi units or pi rotation of angle, and then we get the next solution, then we go pi more, we get the next solution, and then we go pi more, and so on. And in the same way we can combine the 2 and the second and the third, and we get theta is equal to 2 pi over 3 plus k pi. So this will be your general solution. Now to find the particular solutions, we do as we have been doing. So we can use these two equations. So primary solution. So theta will be equal to, when k is equal to 0, we get, actually it's a good idea to mention the k. So at k is equal to 0, theta is equal to pi over 3, or theta is equal to 2 pi over 3. When theta k is equal to 1, we get pi over 3 plus pi. So do on a side or on a separate paper, like a scrap work. So we have pi over 3 plus pi. So it gives me 4 pi over 3. See, that's why we combine them. Okay. So then we are getting the 4 pi over 3. And then from here we will get 5 pi over 3. And these are our solutions. These are the primary solutions. Okay. I think this was the last one. I just want to show you one more thing, and then we were done for the semester. And good luck with the exam, and good luck with the next class. Hope you all get to Calculus 1 and enjoy. And remember, this stuff that you are learning in chapter 7, this is very important for Calc 1. Okay, just want to show one last example. So if you have sine of theta over 3 equals to 1/2. Now what? So remember, we can have sine of 3 theta equal to 1/2, and I showed you how to be able to figure that out. So the same thing we will do here, but this time, so you what happens is, when you have just sine of theta equal to 1/2, you get two primary solutions, and then you get, you can of course write the general solution using those two primary solutions. If you have sine of 2 theta equal to 1/2, I showed you that you will get now 4 primary solutions. So, and if you have sine of 3 theta, you'll get 6 primary solutions. But what happens when we have something like this? Theta over 3 is equal to 1/2, or theta over 2 is equal to 1/2. So let's see what happens in this case. So if we have this situation, sine of theta over 3 is equal to 1/2, then it means theta over 3 equals, so remember 1/2 is 4 pi over 6 and 5 pi over 6. So theta will be equal to, and now we will multiply by 3. So it becomes pi over 2 and 5 pi over 2. So the general solution will be theta is equal to pi over 2 plus 2k pi, and theta is equal to 5 pi over 2 plus 2k pi. But what is 5 pi over 2? So let's see. So remember, this is 1 pi over 2, 2 pi over 2, so 3 pi over 2, 4 pi over 2, 5 pi over 2. So can you see the 5 pi over 2 is the same as pi over 2? So actually we don't need this one. This is just redundant, means it is it's giving us the same same angle or same value that we already have. And how can we get this value from the first value? Well, when k is 0, your theta will be pi over 2. When k is 1, you get pi over 2 plus pi. You get plus pi? No, you get plus 2 pi, because see here, this is 2k pi. So you are not getting plus pi, you are getting plus 2 pi. So now when you simplify, you get 5 pi over 2. So only this equation will give you all the solutions. So you don't have to write this one. Okay. So can we do that? We discard the first one and keep the second one? Yes, you can do it. But it's always a good idea to pick the equation which is the which uses the smallest angle. Okay, so that is the end of our section 7.5. So I'll see you hopefully on the review day, otherwise on the exam day. Good luck.